Welcome to the Biotech Startups podcast by Egnyte. Join us as we speak with first-time founders, experienced scientists, serial entrepreneurs, and biotech investors about the challenges and triumphs of running a biotech startup. Gain actionable insight into navigating the life sciences industry in each episode as we explore the business of science from pre-seed to IPO with your host, John Chi. The purpose of the Biotech Startups podcast is to provide general insight into the ever-changing world of life sciences through the experience of a variety of guests. The use of information on this podcast or materials linked from this podcast are at the user's own risk. The views expressed by guests and any employee of Egnyte on the podcast are their own and do not necessarily reflect the views of Egnyte or content sponsors. Any appearance on the program does not imply an endorsement or recommendation of any product, service, or entity referenced in the podcast by Egnyte or by its guests.
My third guest is Alok Tayi, founder of Vibe Bio, a life science company focused on funding and guiding high-potential drug programs through value inflection points. Vibe Bio's core is a community of scientists, patients, and partners that are dedicated to helping biotechs find the promising treatments that patients deserve. Prior to Vibe Bio, Alok started and ran several life science-focused software companies, including PreScouter, TetraScience, and the life sciences division at Egnyte. Before diving into the world of startups, Alok was an academic scientist working with George Whitesides at Harvard, Sam Stupp at Northwestern, and George Whitesides at Cornell. Over the next 3 episodes, we cover a wide range of topics, from his early foray into material science, his serendipitous academic career, which included a JSPS Fellowship in Japan, his trial-by-fire entrepreneurial journey, and his experience founding both the Biotech 2050 podcast and Vibe Bio. Today, we'll chat about the early years, covering Alok's introduction to nanotechnology at 15 years old and how the foundational experience of pairing software and science has remained present throughout his career. We'll also chat about the life-changing mentors he met at Cornell, Northwestern, the University of Tokyo, and Harvard. Without further ado, let's dive into episode 4 of the Biotech Startups podcast. Alok, it's great to see you again. Thanks again for being willing to jump on the podcast.
Yeah, really appreciate the opportunity, and big fan of what you're building at Egnyte, and happy to be a guest today.
Yeah, thanks so much. And when I was talking to the team about where would be a fun place to start, we were thinking that maybe we could turn the hands of time back, and so listeners can really hear your experiences and really learn vicariously through kind of what your journey has been thus far. So to jump right into it, what was your childhood like? How did you get into science and entrepreneurship?
Yeah, I think my journey into science, which was sort of my first kind of professional experience, started very young. I grew up in upstate New York, near Albany. And the thing about Albany, which folks may not know, is that in Albany, there was the first nanotechnology university was actually started in town. And so when I was a kid, most when they were young, their first job is doing a paper route, delivering papers door to door. I, however, at the age of 15, 16, my first job was actually doing lab automation for nanotechnology.
Wow.
Where I started very young, building software and hardware to test nanomaterials and how they interacted with dangerous chemicals. Wow. And so that was a really interesting experience in that I got a chance to learn a little bit about software, a little bit about hardware, work in a laboratory, learn what this new burgeoning field of nanotechnology was. And I spent a couple summers kind of doing that. I worked for then an assistant professor, now probably a full professor and beyond, a guy named Michael Carpenter, who's just a really nice, warm individual, very supportive, and was very hands-on and helpful whenever I had issues. And I think it was that sort of early on experience that enabled me to feel confident being in science and also help nurture my excitement around this unique combination of software and science as a whole. And I think that thread kind of has tied together through the majority of my career in the future. I often joke with my colleagues that many of my friends who had a similar sort of background experience, the smart ones chose going the software route. I instead chose the material science and the nanotechnology route, which I think still worked out fine, but was definitely a different path compared to the former.
Absolutely. And I mean, this is the first time I've ever heard of a program for at the age of 15 or 16. And like for a 15 or 16, like when I was thinking about my 15 and 16-year-old summer, I was working in retail. And I was like, so this sounds like a great opportunity. Was this kind of driven kind of like, oh, you're like, this sounds really interesting to me? Or was it something that was like family has always been kind of like, hey, science is the place, or what sparked that fire to even apply for that role in the first place?
Yeah, I think it was just luck, to be honest. My dad is an academic. He teaches business. My mom's a lawyer by training. In both those cases, they obviously made sure that education was important, but never specifically pushed me down like one explicit direction. I think it was really just an issue of luck where I had nothing to do for a given summer. My dad commuted to the similar kind of part of town where the lab was, and they had just set it up and just gotten funding from the state. And so we're looking for people to help with, some projects over the summer and kind of get things going. So I just kind of applied, got a chance to meet with Mike, and then kind of went from there and spent a couple summers kind of doing that, both in high school and then a little bit in college as well. But I really credit that experience as sort of helping me see the opportunity that existed at this intersection of tech and biotech. And yeah, at the end of the day, it was just an element of pure happenstance.
Yeah. Wow. I think when I reflect on kind of like my journey, it was I would say I had a little bit later. It was more in kind of like late high school and college when I kind of found and someone who kind of like took me under their wing. And there's a handful of professors who kind of did that. And it sounds like Mike did that for you and, kind of took you under his wing and kind of showed you the ropes. And I'm going to assume kind of like, was the inflection point and got you, down the path of like material science and probably in your university experience, just inspired you to pursue that going forward?
Oh, absolutely. I think it's safe to say that when you're young, you're shaped most by your best experiences and your worst experiences, right?
Yeah.
And I think in this case, early on, I was fortunate to be shaped by a bunch of positive experiences. And we'll talk about it later. But, in addition to Mike at University of Albany, as well as guys like George Malyaris at Cornell, or my PhD advisor, Sam Stupp at Northwestern, or George Whitesides at Harvard, right? I think definitely had a fortune of being surrounded by really smart, caring individuals who wanted to help support the next generation of scientists. And so I think in the case of my high school experience, just having a positive environment where it's okay to fail and make mistakes. Science is not easy, and there are also ways in which we can do it in a more efficient and rapid manner. And it's cool to explore that as well, in addition to kind of the basic science of what we're doing. I remember when I was in the lab, this was at a time when nanotechnology was first starting to become really big and starting to become like a thing. One of the first like nanomaterials companies was also founded in the lab and run out of the lab like a couple doors down. And so we also had this unique access to like materials and technologies that no one else in the world had. So I think it also was, again, a unique opportunity where in addition to being able to have a really supportive mentor and advisor, also had, I think, some unique technologies that no one else had really at the fingertips, literally, to be able to experiment with and see how they operated. So I think that also helped lay a firm foundation for what I wanted to do in the future.
That's so cool. To be honest, like I'm super jealous. I am super jealous. And so you'd mentioned now, after high school, going to Cornell. What was your experience there like? In the lab, on campus. Did you have a similar experience finding you mentioned some mentors there? What was it like at Cornell?
Yeah, Cornell is an awesome environment if you're interested in science and engineering. I studied material science myself in part because of the experience I had from high school. Coming up in an academic family, I also had a lot of conviction that I wanted to become a faculty member one day and become an academic. I feel when I talk to younger folks these days, that's like half the battle is just knowing what it is that you want to do.
Yeah.
It's okay to change, but at least having some conviction and direction certainly helps a lot. So going to Cornell was a great opportunity for me. I remember one of the first people I met even before I applied to Cornell was a guy named Steve Sass, who was a professor at Cornell. He was a professor in the material science department and sort of was one of the sort of storied figures in the area of like X-ray crystallography and material structure. Obviously, a core fundamental underpinning of a lot of the field. Yeah. And so I remember meeting him even before I applied over the summer, sort of sharing with him a little bit of the science that I had done in high school. And I was like, I remember showing up and I was like a little nervous because I'm like, who the hell am I to like, meet with someone like him and like sort of share a little bit about what we're doing. But he spoke to me just like he would like any of his peers and did the same in addition to sort of sharing a little bit about my science. He shared with me a little bit about some of the work that he was doing too, which I thought was really cool and exciting. So it was a very positive and enriching environment, especially I think the material science program when I was there became pretty popular, especially post like the dot-com burst. And so Cornell was a great experience where I think a lot of the scientific underpinnings that I had at Cornell really helped for the future of my scientific career. I spent a lot of time in the lab of a guy named George Whitesides, who did a lot of organic electronics, which were like the early days of figuring out how plastics could actually be used in things like solar cells and LEDs, et cetera. And now I think the vast majority of phones are based on that sort of technology. So he too is also a very supportive, very optimistic individual in science. I'd say that was one thing that as you move forward in life, especially in a scientific realm, that level of optimism is something that you often miss, I think, in many cases, especially in biotech. Yep. But I was very grateful to kind of have that experience there. Made some of my closest friends, even till this day, right, from Cornell. And I think a big part of it is just, syncing up and meeting with other people of similar mind, attitude, values, and maintaining that over time. So yeah, I think Cornell was a great experience, and really seeing George's excitement and love for science really helped kind of, I think, solidify that for me and motivated me to do a PhD as well.
That's awesome. I mean, and I completely agree. The optimism, and sometimes it's hard because it feels like you're running through walls, and there's only so many walls that you can run through in a given period of time. And it's incredibly refreshing and exciting. And I had the same experience at Berkeley with a couple of professors who kind of were honestly cheering you on and wanted to see you succeed. And I was in a similar path too. At one point in time, I was like, maybe I could be an academic. And then I was like, seeing my peers who ended up, following that track, I was like, you guys have something that I don't have. Like you guys are built different, but I am glad that academia is, will be in your hands in the future. And so as you're, it sounds like Cornell kind of laid the foundation for your graduate studies. What drove you to choose Northwestern? And was there a particular lab that you wanted to be a part of? And what was that decision making for you?
Yeah, I was really fortunate that there were a couple of good schools in the material science space. This was sort of late 2000s, as well as a lot of faculty, I think, that had produced a lot of great students and professors themselves. So for me, it was really an analysis around where do I think I can resonate the best in terms of the culture, the attitude, the people. Where do I think I'm going to have the greatest rigor and quality of science that I can be done? But also I kind of did a quick back of the envelope analysis of where did all the professors who I admired went to school, right? And it turned out Steve Sass did his PhD at Northwestern, very much kind of goaded me in that direction. And that's where I ended up going. It was also a fairly sizable program, at least comparatively. I think when I was there was maybe 40 to 50 students per class. So it was quite a sizable place. And I really think my love for science and a lot of my scientific experience and rigor was really established there. Joined in part of material science for my PhD. Ended up working for a guy named Sam Stupp, who's a pretty well-known scientist in the supermolecular chemistry space. When I joined, he was appointed in material science, chemistry, and medicine. Was probably the best kind of scientific experience any PhD student could have. I remember in some of our early meetings, when you meet with Professor Stupp for the first time, he tells you that, his lab is, to be successful in his lab requires that you be highly self-motivated, and also that, you push him as much as he pushes you.
Oh boy.
And I was like, okay, challenge accepted.
Yep.
So Northwestern was an awesome experience. I loved Chicago, loved working for Professor Stupp. And I think the piece of it that was interesting for me was that one, there had been for better or worse, there had been several successful alums of the lab who all had gone to Cornell in material science for their undergrad.
Oh, wow.
So yeah, there's like 3 or 4 of us that literally generation after generation had come from the lab. And so Professor Stupp was he's trying to pattern match. So he's like, oh, you remind me of these 3 other people. So yeah, sure, I'll take you to the lab. But the other part of it that I thought was a lot of fun was the fact that I had a little bit of scientific experience and research experience previously. You were given a lot of latitude. So I remember when I was joining the lab, I was trying to choose a lab that, one, allowed me to work on really interesting science that was sort of at its cutting edge and that I thought would be relevant longer term. Second, work for a lab that was sufficiently well financed and staffed such that you didn't have to worry about whether your project would get canned because grant money didn't come through, etc. And then when it came to a research area, I was particularly keen on focusing within a domain where I had very fast cycle times. And I remember that being a very critical piece of what I wanted to do, because I had seen a lot of friends who worked, say, in the biology space, as you had, and I'm sure your peers have. Love biology, huge opportunity there, and a lot of great science is done. But I think it's safe to say in some of the fields of biology take forever to get results, right?
Absolutely.
And so in my lab, in the Stupp lab, we had this really unique mix where half the lab, maybe a little more than half the lab, maybe 60, 70% of the lab was biology, biomaterials work. We had folks doing oncology-based therapeutics. We had folks doing neuronal regeneration, right? A lot of really core biology work. And the other sort of 30 to 40% were doing electronics and electronic materials. And so I was fortunate enough to be able to work a little bit on the bio side, but spend the majority of my time in the electronic materials space. And I remember I had a colleague who was in a similar year as me, but in the bioengineering side of things. I'd go run an experiment. It would take me 24 at max 48 hours to get results back, and then I can iterate. For him, he was working with neurons, and it took him at least 3 months to differentiate and run his experiment. So I'm sitting there and I'm looking at him, I'm analyzing data. I'm like, what do you do? What do you do in that case for those 3 months when you don't know what the results of the experiment are, right?
Cross your fingers.
Yes. Curious. Well, I don't know if you've seen that across biology, but yeah, that would always kind of weigh on me as oh man, I have to wait this long to get results. But curious to hear how you wrestle with that.
Yeah, that was absolutely it. And I think part of it, one, just foundationally, it's, it is a much longer kind of cycle, just like that type of research. And that problem was compounded for us because of the lack of equipment. So you're okay, it's time to go borrow Professor Portnoy's microplate reader, and because they have luminescent capabilities, and you run down the hall, and then you have to, sometimes in the core facility we'll have a list, you're on the waiting list, and you're okay, so at 3 p.m. I can go use the thing. So that just further elongated the cycle, and it was that's one of the walls that we had to run through was okay, how do we knowing that the assays are going to run for a really long time before we can actually get data with any sort of statistical significance. And it just gets elongated every time you have to go share a resource. So that was kind of one of the inspirations for Exceeder. But I completely empathize and relate to that experience.
Yeah, absolutely. I remember sitting in a core facility at Northwestern watching a video interview that Elizabeth Irons did about science exchange at the time. And she was talking about that same problem where, there's a lot of equipment out there in labs, in core facilities, not being utilized. And, Elizabeth and I actually are now quite good friends. And so that point that you made around just time and friction and access is, I think, further accentuates the challenge of keeping people in the scientific discipline.
Plenty of colleagues who actually have left
Yeah.
this completely because of it is like, it's just so painful. It's like absolutely painful. And it's a shame because they were, I don't want to say that this is like how it always is, but like I remember like the program initially, they were so fired up and kind of got grinded down.
Yes.
And that it bums me out, frankly.
Yeah.
I would love them to still be participating, but I think we're now seeing kind of before everything was super, super difficult, and now things are just like singular one super difficult. Like instead of like, yeah. So but yeah, I kind of like that optimistic streak in me. I'm hoping that things continue to get better. And I think, what we're seeing is that things will. But after Northwestern, I know you ended up going to University of Tokyo and Harvard. Which one was first? Was it University of Tokyo and then Harvard, or the other way around?
Yeah, great question. So I ended up spending some time at Todai at the University of Tokyo before doing my postdoc at Harvard. A big part of why I sort of took that road actually was sort of rooted in at Northwestern. While I was doing my PhD with Sam Stupp, again, by chance, I remember vividly working on my initial work, my PhD was around electronic materials, and specifically, how can we use this mix of organic semiconductors and carbon nanotubes to design solar cells and different types of electronic materials. And it was going okay, it was going fine. And then I got an email introducing me to a PhD student named Alex Schwede, who was a PhD student in Fraser Stoddart's lab. Fraser Stoddart, who was previously in the chemistry department at UCLA, had just moved to Northwestern to the chemistry department. Fraser ended up winning the Nobel Prize in 2016 and was one of the pioneers of the space of molecular machines. And one of his students, Alex, who was actually an electrical engineer, or physicist rather, became a synthetic organic chemist to move to Chicago with Fraser, ended up discovering by chance this really unique crystal. He had mixed two chemicals together with the expectation of creating a catenane, a ring, where both of these compounds would fuse covalently to create one single molecule. I guess he forgot to add like a catalyst, then tried to crystallize the material and ended up creating this absolutely beautiful periodic charge transfer complex, which basically alternated positive, negative, kind of attractive molecules. And he started doing a chemical search, it's like a literature search, like what is this good for?
Yeah.
And he turned out to find a class of molecules and materials called ferroelectrics, which can basically use a sort of a form of computer memory. They can hold kind of a state 1 or 0. What we ended up doing is collaborating, and he's like, hey, look, I don't know anything about electronic materials. Turns out you guys might know something about this, but I just created this entire class of like crystals. And then that was like literal serendipity. We're really fortunate. Alex and I just became one really good friends. One of his other colleagues, Andy Su, who's now a professor, I forget, I think Tianjin or Shanghai in China. Andy also was an electrical engineer who then became a synthetic chemist. So we had this really unique mix of like material science people who were spending time in chemistry, then physics and electrical engineering people who then were spending time in chemistry. And none of us really were experts in synthetic chemistry, but we were really excited about the potential of using it in unique ways. So in that circumstance, we ended up realizing that what Alex had kind of stumbled upon was actually an interesting structure that we could routinely and scalably create these extraordinarily large materials that had essentially ferroelectric capability, and ferroelectric capability specifically at room temperature. all the historical examples and the natural materials that have been found were actually only observed at like below liquid nitrogen temperatures. So he was able to do it because he used some of this really unique kind of capabilities of supramolecular interactions. And so that became the foundation, the new pivot, a foundation of both his thesis, my thesis, and others. So that was, again, another aspect of serendipity. And I just became really in love with this concept of, how do we design and engineer molecules to be able to align and organize themselves, self-organize into interesting structures. So having spent time with Fraser and Professor Stupp, I want to continue on that path. And so one of the other really great minds in this space is a professor named Takuzo Aida, who's at the University of Tokyo. And so turns out that Professor Aida and Professor Stupp were really close friends. And so got a chance to be a JSPS Fellow in Takuzo's lab for a little bit of time. And so that was also a wonderful experience, in part because it showed me a completely different culture for how science is done, and one where, Professor Aida's lab, he has an extraordinarily high bar for science, like extremely high bar. All the people I worked with did. But in Aida's lab, you only publish in Science, Nature Materials, JACS, and that's it, right?
Oh my God.
You have to be above a certain level of science in order to be able to publish in that lab. And so I was really fortunate in that I was, I think, the first student from Professor Stupp's lab to go and work in Aida Sensei's lab. And while there, got a chance to do some really interesting research, publish a paper in Nature Materials, and then also got to teach actually a few classes.
Cool.
And so there weren't a lot of folks who were native English speakers, obviously, and they wanted to do more classes in English. So got a chance to kind of do that as well. So that was a really great experience. I must say, of all my colleagues that I've worked with at Harvard or Northwestern or Cornell or elsewhere, my colleagues at the University of Tokyo by and far worked the hardest.
Oh, man.
We were in the lab probably 10 a.m. to 10 p.m. 6 days a week. And if you are a professor in the lab, you then were there also on the 7th day as well. So it was a intense experience. But yeah, it was a long-winded answer to your question.
No, that's fantastic, because I was like very curious about that experience, like contrasting to an American lab experience and a lab experience in Japan. Obviously, there's like tons of cultural differences in terms of the approach to work as well.
100%.
And I guess in addition to being in like an incredibly rigorous labs, were there any other kind of like differences in like kind of processes and methodologies that they employed in Japan that you kind of like I would imagine you took home with you as you came back?
I think the culture there was very unique and different. I think it would have been hard to actually transplant a lot of those same concepts, because the mentality and the focus is so different. Now, keep in mind, the way I kind of think about it is, in the US, we have this interplay between life, school, work, extracurriculars are valued pretty extensively. In Japan, you have, I think, a lot less time and space and disposable income to do like extra stuff. So people spend a lot more time like working and in the lab, and that's just part of both the work ethic, but it's also, I think, a key part of how they build their social network, right? Like the people that you work side by side with are the people that you kind of spend time with and kind of get to know and advance your relationships with. So I think the key part that I sort of took away from that experience was really the work ethic. And the high bar and rigor around science and novelty. I think that definitely served me well when I went to Harvard, but I think many have an opportunity to learn a lot from how science is done in those sorts of spaces. I think that's also a culture where there is some element of hierarchy, but there's also a lot of collaboration, I think, especially amongst folks who are sort of at the bench. And I think that's something that I definitely try to bring forward, is not only collaboration within the lab, but also in adjacent areas. Just in the same way when I was working with folks from Fraser's lab, we were from very different walks of life and very different departments and backgrounds. But I think there's a huge opportunity when those sort of sets of skills and perspectives come to the table.
Absolutely. And I mean, and your colleague, when just serendipitously just stumbling into such a profound discovery that then kind of like cascades, and it seems to have this like ripple effect across, across scientific disciplines. It's like, it's stuff like that. Like, I mean, not to say that there's not a benefit to just like having the blinders on and just like focusing. There's absolutely a time and place for that. But I think I found on my side too, that kind of cross collaboration and cross pollination of ideas, thought, and style is really, one, refreshing, and two, just takes you down paths that you never thought you would ever go down, like ever. And I think Berkeley kind of had the kind of more leaned, for when I was there, leaned towards having the blinders on. Like, you do this and you do it really well and you go really, really deep. But as I left, they actually created the building, which was a cross-disciplinary building, like the new Li Ka-shing. It's not new anymore, but the Li Ka-shing building, which had exactly what you described. There's like, the folks like the MCB folks, the hard chemistry folks, like, all like, and it was an interesting design. It's kind of like an asterisk. So, and they like kind of a cross. And so I've always found that on my side too, that collaboration is something I carry with me. At least I try to my best within Exeter. And also what really resonated with me as well was how, the bar, the rigor, just like setting the bar high. I would say I was like, when I was younger, my bar was high, but like not crazy high until I met, a couple of Professor Lightman and Professor Volpe at Berkeley. And they kind of, they were nice about it. They kind of like elbowed me. It's like, hey, step it up. Hey, step it up. And same with my co-founder. He's like, hey, step it up. And then the rest is history. Is like, it kind of just like your base level is just there. And I think what, at least at Exeter, I try my best to be like, hey, we're setting it high, and like, let's like try our best to get there. It's okay, understandable, you can't hit it every single time, but at least the attempt to get there is like, that's what really matters. But yeah, that experience sounds amazing. I'm also jealous because I love going to Japan. My wife and I go there, for vacation and stuff. So I would imagine even like enjoying the good food and stuff was probably like a nice aside. So you're now at Harvard. Tell me a little bit about that experience. Like, did you already know, like, kind of already while in Japan, you're like, I'm going to be at Harvard next, like, this is the next stop? Or was there a time where like, okay, I'm trying to do the selection process again?
Yeah, no, I was also really fortunate that I think my PhD advisor, Sam Stupp, and George Whitesides had risen up together sort of as academics early on, and had collaborated. I think we were collaboratively on like a joint DARPA project together. Cool. So they had known each other, and George, for those who aren't familiar, is probably one of the top chemists by H-index, inventor of the microfluidics, self-assembled monolayers, early innovator in NMR, right? Like old OG synthetic organic chemistry, right?
Super OG.
Yep. And on top of that, was one of the few labs, and granted, this is like in the 2010s, so it still wasn't cool yet to do startups. But dating back to like the 80s, started some of the early anchor biotech companies in Boston, Genzyme, Geltex in the Bay Area, Theravance, amongst others, and about a dozen or so companies, about 30 billion in market cap value. And I think out of his lab, something like 200 plus professors had emerged, right? Having been former PhD students, postdocs, et cetera. And so for me, it became kind of clear that, I wanted to go be an academic. I was still interested in being an academic. George's lab, especially at this interface of material science and physics and chemistry, was sort of the place to be. And I just got really lucky that at that time, Professor Stupp kind of made an intro. I remember I was at a conference in Italy on supermolecular chemistry, which is actually at that conference, I was able to secure my position at the University of Tokyo, and also my postdoc with George. Cool. I remember having a conversation with George over a glass of wine. And I remember asking him a question about like strategic thinking and like, how do you make strategic choices around what direction the lab goes in. And he sort of shares kind of his thoughts at the time. And at the end of that conversation, he's like, all right, you have an offer. Let us know when you're done with your PhD and you can come out. So it was a really cool kind of experience. And I still had like a year or two left to finish my PhD and spend time in Tokyo, and then went. But went to Harvard as my first time kind of living in Boston, moving from Chicago. There was a little bit of a change. Really interesting experience there as well. It's at a time when the majority of the lab, which was about 40, 50 people or so, were all postdocs. There were very few, there's like maybe one or so grad student.
Wow.
I think, so this is like about a decade ago. So George was probably in his mid 70s. And so still the sharpest person in the lab, even at that age, and probably one of the smartest minds that still is alive today. Really amazing experience. And I think when I look at the three kind of faculty that I've worked for, whether it's other George at Cornell, Professor Stupp at Northwestern, Professor Stupp, I remember in every group meeting, no matter when it was, and we had group meetings on Saturday mornings, he would still have the excitement and the twinkle in his eye whenever he would see new science every day. Every time you met with him, every time you sort of showed him new data, every time there was a presentation. And in George's case, he also was excited by science, but George brought a completely different perspective and thinking to science. And what I took away the most from that experience was, how does one think, just generally speaking? And what helped, I think, catalyze that mindset shift for me was, for every presentation you gave in the lab, you had to open with a quad chart. And a quad chart might not be familiar to most, but if anyone who does any work with the Department of Defense or DARPA, basically they have a set of questions that they sort of effectively care about when it comes to any sort of piece of technology, work, investment, etc. And George brought that rigor to the lab. And he brought that rigor to the lab because he didn't want to work on stuff just because it was interesting. He wanted to work on it because it would have an impact and it would solve a problem. And so he would always pepper people and teams with questions that seemed innocuous or simple or annoying, like, who cares, right? Yeah. Why does this matter, right? And so I think that mental model and that level of focus has been absolutely critical, along with the creativity that he also brought in, being such a brilliant mind. And I think it was that sort of pairing of distilling down to the most critical facets of what's important in an experiment and science and a pursuit, combined with the creativity of doing it in completely different ways, that from a first principles understanding could work, right? That I found to be incredibly valuable in the lab. And I know for many of my colleagues, some of which who aren't even in science anymore, but for many of them, I think they still take that same level of thought process and creativity, I think, to the work that they do as well across, all these alumni.
That's amazing. I always kind of, my team probably gets tired of me because I sound like a broken record, but just like asking why, just why, yes. like until you just get all the way down. And, the first times they're like, oh, John is so annoying. like stop. And I would imagine the same, that kind of feeling in the beginning, you're just like, whoa, who cares? That's kind of like off-putting. But then you kind of like get into it, you're like, oh, this is how you get to like the true crux of it. But that's amazing.
That's all for today's episode of the Biotech Startups podcast. We hope you enjoyed our insightful conversation with Alok Tayi, covering his early introduction to the sciences, his academic adventures, and the insights he gleaned from working in various labs, both overseas and at home. To learn more about Alok's journey, be sure to tune into our next episode. If you enjoyed this episode, please subscribe, leave us a review, and share it with your friends. Thanks for listening, and we look forward to having you join us again for part 2 of Alok's journey, for an in-depth discussion of his entrepreneurial journey, founding PreScouter and TetraScience, as well as scaling Egnyte's life science business unit. The Biotech Startups podcast is brought to you by Exceeder. Don't want to miss an episode? Make sure to search for Biotech Startups Podcast in Apple Podcasts, Spotify, and Google Podcasts, or wherever you get your podcasts, and click subscribe. To learn more about our leasing program, visit our website, www.excedr.com. We provide research labs with equipment leases on founder-friendly terms to support a path to exceptional outcomes. On behalf of the team here at Excedr, thanks for listening.